Hey everybody. So today's video is going to be about voting systems. So a voting system can be any system where multiple people are trying to achieve one outcome and they have to agree on the outcome. So the most classic example that I can think of is going to be just a general election. So let's say, for example, we have some kind of political compass and we have a red party, which I'm going to put around here on the compass, and the blue party, which I'll put around here on the blue compass. Now let's just say, for the sake of argument, that everyone is roughly equal on the compass. There's going to be some people to the left of the left-wing party, some to the right of the right-wing party. And we hold the election, and there's 100 people in our society, just to keep things really simple. So there's a red party and a blue party. And let's say that after the election, the blue party comes away with 47 votes. The red party ends up with 53 votes. Now, here the red party wins. Not by much, but the red party did win. And it feels like sort of the red party should have won, right? This is a very fair system. Everyone voted for who they actually liked the most. Nobody lied with their vote. Everyone had a preference. And even though these 47 people aren't going to be happy, the red party won, and that makes sense. This is what we consider to be like a fair outcome in voting, right? Fair outcome. Now, it gets a lot more complicated when I add a third party, and I'll explain sort of what I mean by that. Let's say we introduce an orange party, and the orange party is sort of ideologically quite similar to the right-wing party, but let's say a bit more. So we're going to put the orange party here-ish, right? And now let's do the election again. So this time, the votes are going to be between the blue party, the red party, and the orange party. Now the blue party is still going to get its 47 votes, which makes sense because everyone who preferred blue to red is definitely going to prefer blue to orange, so they're also going to vote for blue. But it looks like here orange is going to steal away some of red's votes. Because for example, for someone who was here on the political compass, they were originally voting for the red party because it was closer to them than the blue party. But now the orange party looks even better to them. So let's say that now the orange party takes about 20 of the red votes away, and the red party still comes out with a respectable 33 votes. Now this time the blue party won. So what's interesting here is that the blue party and the red party weren't really being changed at all in both scenarios. All I've done is introduced a third party and it's changed the outcome of the election. Now this feels unfair, right? There's something unfair about this. It shouldn't be the case that a new person entering the arena changes the outcome of the game. And I'm going to talk more about this and other voting systems that are proposed to fix this problem. So in a regular election, sometimes what would happen is that these orange people would be aware that the orange party aren't going to win. And so let's say if you technically prefer the orange party more, but you know the orange party aren't going to win, and you really prefer the red party to the blue party, what you might end up doing is switching your vote to the red party, taking your vote away from the orange party. Now if everyone who prefers the orange party does this, the red party will still win, and that's fine. But now we have another problem, which also feels a bit counterintuitive to a democracy, which is that players should not be voting for an option that I'll say players shouldn't be voting for an option that isn't their top pick. So here, the people who voted for the red party who actually preferred the orange party, in a sense they kind of lied with their vote. And I think it sounds obvious that when we create a voting system, we don't want this thing to happen. This is called strategic voting, and it happens a lot in every country. And obviously, it doesn't make for a very fair voting system. When people are lying about their votes, there should be no perverse incentives in a voting system. So let's talk about some solutions to this problem. One very quick solution is what's called a ranked choice voting system. So let's say in a ranked choice voting system, let's say there are 3 options. Once again, we have option red, option orange, and option blue. And let's say that this time everyone in our society gets to rank the 3 options based on what they like the most, the second most, and the third most. So let's say we have 3 people, person 1, person 2, and person 3. And they're each going to rank the party's best, the top one, the bottom one, and the middle one. And let's say, for example, person 1 likes, let's say, I'm just going to fill it in. Alright. So person 1 prefers red the most, and then orange, then blue. Person 2 prefers orange the most, then red, then blue. And person 3 prefers blue the most, then orange, then red. Now this wouldn't actually really happen with the political spectrum I showed earlier, but it doesn't really matter. And again, we can't really reduce politics to a one-dimensional spectrum anyway. This is something that very reasonably could happen in a voting system. So ranked choice voting just tells us that everyone gets to submit a ballot with a ranking of preferences. It doesn't tell us anything more about what we need to do with that ballot. And so from there on, there are different ways that we can create a count and see which wins. One classic example is what's called a border count. Now a border count is very simple. All it does is it assigns a point value to coming in each place. So let's say if you come in first place, you get 5 points. If you come in second place, you get 2 points. If you come in third place, you only get 1 point. And then it's as simple as just adding up the scores for each of the items. So red got 1 of each place, so red will come away with 8. Orange got 2 seconds in a first, which means it has 9 points total. And here the blue party will come up with 7 points total. So in a border ranking system of this nature, the orange party will win. This is fine, and this feels really reasonable. One issue with the border ranking system is that these numbers feel quite arbitrary. Right? There's no reason why this had to be a 5. It could have easily been a 4 or a 3, and you can see how that will impact the outcome. Even if you make these numbers linear, like just 1, 2, 3, it still feels quite arbitrary. It feels like liking something the most should be somehow, there should somehow be a bigger gap between these two than there are between these two, because liking something the second most versus the most feels like a bigger step in your claim about a thing than just going from like third to fourth or something like this. But anyway, this is one way that you can handle a problem like this. You could also have ties, and ties could be an issue. Now let's talk about another way we can handle the problem like this, and that is with something called instant runoff, an instant runoff system. I'm going to write that down here. So an instant runoff. This is how I wish most countries' elections would work. Right. In an instant runoff system, let's just keep the same ranked choice preferences. What we do is we look at the 3 candidates and we start by figuring out which one has the least votes. So everyone's going to vote for a candidate, and whichever one has the least votes is going to be eliminated from the voting. So let's say in our first round we have all 3 still in, and if everyone was to cast 1 vote for their favorite, there's going to be 1 vote for red, 1 vote for orange, 1 vote for blue. Now there's a problem because we're looking for something to eliminate. So let's just say that if there's a tie, we let everyone cast a second vote for their second favorite option. And now you'll see there's going to be 2 votes for red, 3 votes for orange, but only 1 vote for blue. So clearly now blue will be eliminated. So after round 1 of my instant runoff system, blue was eliminated. And now we do a second voting round. I say voting round, everyone only has to cast 1 ballot, but we're going to sort of analyze the data a second time. Now we're going to do the exact same thing again, but just between the red and orange parties to see which one wins. And you can see player 1 prefers red to orange, but players 2 and 3 prefer orange to red. So in this scenario, red would be the next one to be eliminated, and orange would win in my instant runoff situation. Now this feels a lot more fair. And in a ranked choice system, it seems like people aren't going to be doing this thing that we don't want to do, which is lying about their preferences. And now I'm going to show you a problem with instant runoff. And I've got a little example drawn out here that I'm going to put up on the board. imagine that we have some land, some area. Maybe it's a country, an old-timey country, and it's broken up into 4 villages. And let's say that all 4 of the villages combined, as in the whole country, need to build something important. Maybe it's a monument, maybe it's an airport. The idea is that it can only be built once in one place, and everyone's going to have competing interests about where it's built. So let me just start by placing down some cities and giving them populations. Let's say we have a city here. We'll call this, let's say it's got a population of 26. And let's say we have a, oh actually no, let's make this 42 actually. And now let's have another city up here, city B. We'll give it a population of 26. We'll add another city here, city C, which would have a population of 15. And finally over here, we have city D, which is going to have a population of 17. Alright, let's just, I might change the colors a bit for the letters to make them more distinguishable. So we'll have, this is A, this is B, this is C, and this is D. Alright, so these are the cities. You'll notice there are 100 people total in the country. That's fine, that's just for simplicity. And we have 4 options for where we can build this airport. It can go in city A, city B, city C, and city D. And clearly, if everyone was to just take a vote, a standard vote like we did at the start of the video, on where that airport should be, city A would win. Which makes sense, because it would get 42 votes, because everyone's just going to be voting for their own city, presumably, and city A would win. Now, an interesting question to ask is this outcome fair? Because the thing with the most votes won, but also for everybody else, which is mind you the majority of people, these are 58 people here, for everyone else, they got their worst preference. These people would all rather it be in one of these 3 cities than it go to city A. So this feels unfair. So let's again employ the instant runoff idea. And we're just going to say that everyone's ranked preferences in every city is going to be their city first, and then the next closest city, and then the next closest city, and then the next closest city. So for example, if you're in city D, your preferences are going to be D first, and then C, and then B, and then A. That's a preference if you're in city D. Alright, so let's go through the ranked choice system. Well, we've got 4 options, A, B, C, and D, and everyone votes for their top pick. And we take everyone's first ranking, and it looks like city C is going to be eliminated, because city C only got 15 votes, which is the lowest amount. A's got 42 votes, B's got 26 votes, D's got 17 votes, and because C, their closest people at B, that means that all the votes from C are going to be absolved by D, so by B rather. So now B has their 26 votes, plus the 15 people from C are now going to be voting for B in the second round, which means that this city is now going to have 41 votes. Yeah, cool. All right. And now we vote again. So we're going to vote again. And again, everyone's going to vote for their best option out of what's remaining. So A is going to get 42 votes, B is going to get 41 votes, D is going to get 17 votes, so D will be eliminated. And all the votes from D are going to be passed over to B, which means that B will have a majority of the votes, which means A will be eliminated next, and B will win in an instant runoff system. So I've changed the rules of the voting system a little bit, and this time B has won. This feels more fair, everyone had a bit of an input, and everyone got something broadly okay. The people in A aren't going to be very happy, but we've made most people in the system more happy. Now, here's a huge problem with this system, is that some people can be a bit cheeky and do this thing that we want to avoid, where they lie about their preferences in order to get a competitive edge. And let's slowly explore a way that can happen. Now, like I was saying before, if you're living in city D, these are what your preferences should be. D first, then C, then B, then A. But if you're in city D, you can foresee what's going to happen here. So you know that at the end of the game, B is going to win. Now, you would rather C win. Only slightly, it's a bit closer to C. Only slightly, but you would rather C win than B. So if you're in city D, here's what you could do. Everyone in the city could lie about their preferences and say that they actually rank C above themselves, giving all their votes right from the get-go to city C. Now, if this happens, then obviously D will get eliminated in round 1 with 0 votes. And then in round 2, A is going to have 42 votes, B is going to have 26 votes, but C is going to have now 32 votes. Which means that now in the next round, B will be eliminated, and then all of B's votes will be absorbed by C, and then A will be eliminated. Now C wins instead of B. So the outcome has changed because everyone in city D kind of broke the rules of the game. They voted for someone that wasn't actually their top preference. They lied on their ballot, but them lying on their ballot gave them a strategic edge, which is obviously bad. So this is another problem with the instant runoff system. You're still going to have these incentive structures where some players are going to be motivated to lie about what they want, which feels unfair. And some people have proven actually that pretty much all voting systems are going to have problems like this, and that the idea of fairness in a mathematical sense is sort of not real, and that we just have to approximate the best system we can. It seems very obvious to me that a ranked choice system of this nature is way fairer than a first past the post system like they have in the US, but that's just my opinion. Just because we can't get things perfectly fair doesn't mean we can't approach a more fair system. There's another proposed solution, and it's called Condorcet voting. I'm not sure how to spell it. I think it's a weird French word. But the idea is that, let's say if we have, let's make it 5 parties now in our system. So we have an orange party, a red party, a blue party, and a purple party. The way this system would work is we would just do a ranked choice system again, but we would pair everything up against everything else. So with 5 elements, there's going to be 15 pairs of elements. So for example, it's going to be orange versus red. And out of orange and red, whatever one's better, let's say it's orange, gets a point. And then we're going to compare orange to blue. Now let's say blue's orange to blue. And let's say blue's better. Then blue would get a point. We keep going. And obviously if one of the options wins 4 points, that means they've beaten every other option, which means obviously they need to win. But if one of them gets 3 points and another one gets 3 points, they tie. So if these two tie and everything else gets less than 3, then we just look at these two and how they battled and use that to find the winner. This is also a really nice idea of how to find the winner. But I will show that it does have one flaw. And the flaw is that if everyone ties, it is not clear what we should do to resolve that. So again, let's bring up our 3 options again with person 1, person 2, and person 3. And these are, again, the ranked choices. And I'll fill them in this way this time. Like this, and then now we've got a huge problem. If I look at my matchups here, what wins the most when I go orange versus blue? Well, blue beats orange in 2 out of the 3 scenarios, so blue is preferable to orange. Now what wins more when I match orange up to red? Well, here orange beats red, here orange beats red, but here red beats orange. So overall, orange has beaten red. And what happens when I do red versus blue? Red wins 2 out of the 3 of them, so red is better than blue. So if I was to write this out formally, I would end up with red is beating blue, which is beating orange, but my huge problem is that orange is beating red. So it'd be a complete tie, and it's not clear at all who would win in this tie. In math, there's something called the transitive property, which says that if I take 3 values, this, and if like the first value A is less than B, and B is less than C, then it should be 100% confirmed that A is less than C. This is called the transitive property, and it's true for any 3 integers you can think of in math, for example. It's not true here. Obviously, the transitive property is not being abided by here. We can't rank order these in any meaningful way. And that's one problem with this courtesan method, where you just pair up all the individual fights and count them up. Because what if everything is a tie? Cool, and that's about all I have to say about voting systems. It kind of is quite depressing, I think, the more I've been researching this topic, to know that a true, fair, perfect, unexploitable voting system isn't really possible. And I commend the countries that do things like have many parties in parliament and have more options for voters. I think the more options you have on a ballot, the better. I do really like democracy. I think it's a good idea. And I hope that we can learn from some of this math to develop our voting systems in a more fair way, even though, as we've shown, the system will always be a little bit exploitable. And yeah, that's the video. Cheers for watching.